Let's start. Okay, hi all. Hello everyone. I'm so happy to be here today with all of you. This is Dalia Saif, alumni, senior community manager at Udacity, part of Accenture, and I'm really excited to be here today with all of you in this exclusive and interesting session talking about the power of data and how to transform the open data with AI-driven visualizations. So all of us know that the data is powerful. However, it's like the full potential of a data can only be seen when you have the right tools and techniques to analyze these data and to see the insights from these data so it can help you in decision makings and taking the right decisions and the right results. So I think all of you are here today to discover this together. So please join me in welcoming our exclusive and distinguished speaker, Noble Ackerson. Noble, he's a Stanford-trained expert in ethics and technology, and he's mainly specialized in responsible AI and ML development. Noble has pioneered tools like the Responsible AI Checklist. Mainly, this tool has an objective of empowering AI practitioners to integrate responsible AI practice into their workflow. So please let's welcome Noble. And today we will deep dive into the great topic of open data, and we will discover more how to fine-tune Gamma to select the best visualization components for your data. We will explore how to build smarter data pipelines that boost the performance of your AI model. We will see how to make complex data sets into something understandable through this impactful visualization, and how to apply all these techniques to your own projects. So whether you're a technical expert or you're just starting this field, I think this session will be very important for you. So we will all explore how AI is democratizing access to valuable public data, giving everyone the opportunity to unlock great insights and results. So please, again, welcome Noble, and we will give him the floor to start. Before starting, this webinar is recorded, as you know, and we will share it after the session on the community, in the learner and alumni community. And please put all your questions in the chat box, in the Q&A chat box, and we will have at the end 15 minutes to answer all your questions. Thank you so much, and now the floor is yours. Thank you.
Thank you so much, Delia. Only thing I would add to the intro is that as of last Friday, I'm officially a Google Developers Expert for the AI category, which means I'll be doing a lot more of these types of workshops. And I'm also the instructor for the newly refreshed AI Product Manager Nano degree. I did a lot of sort of the evaluation and bias sections lessons for that. So if you haven't signed up and you're interested, definitely check that out. And so let's jump right into it. There's a lot of content here. And so I just want to sort of jump right in. Today, we're going to look at open data and how you can use tools available to you to get insights. I'm going to start with sort of a problem framing. So $3 trillion, that's the estimated annual economic value that remains untapped because we are not fully utilizing data, right? It's not just a technical problem, it's economic, it is a social economic cost, social opportunity cost, I would say. Open data has, as we all know, in this day and age, facts and data should drive a lot of the decisions that we make, given how governments operate and given how businesses innovate. I think we're not taking advantage of what's possible. We're only scratching the surface. Another point that I wanted to make is that I used to be a coach for Udacity students, sort of grading if you're a learner, I used to grade your VRND and front-end engineer nanodegree courses. And one of the most common feedback, I used to also be a coach. And one of the most common feedback I would give learners was to find an open source project or open data to help hone your skills for your portfolio or your personal repo. And that still holds true today because we're facing what I would call like a paradox, right? On one hand, on the left here, you see, the world is creating a whole lot more open data than ever before. In the US, United States, data.gov alone hosts over 300,000 data sets. And on the right, you can sort of see with that 68% through 73% of available data goes completely unused, right? When we look at government data sets, McKinsey, I think, looked at government data sets across 115 countries. They found out that only 7% were truly accessible and usable is another thing. I used to work for a international development agency called National Democratic Institute of International Affairs. It's a mouthful. We used to sort of see a lot of election data that weren't in the format that was actually usable. So what's the disconnect? Why can't more people extract more value for all of this data that is available? We're going to talk about that today. I'm going to breeze through the why, I think, like 3 examples of why I think that's the case. It's not an availability, as I've just sort of established. It's more accessibility, in my personal opinion. I think open data is only valuable when people understand it. It's normally relegated to being a data scientist or having analytical thinking baked in. Right now, there's a significant gap between the data publication and data comprehension, right? So what if we could bridge that gap, right? That's sort of what makes my heart sing and what I hope you take away today. What if anyone, regardless of your technical expertise, could simply have a conversation with data and receive immediate valuable insights? So that's sort of the main challenge. If you're on this call, on this webinar, you probably have access to, if you have internet, you have access to an LLM by now. And so this, for example, I took a visualization showing the strongest correlation between in this vehicle data set that I found on Kaggle. It's from the University of Washington Interactive Data Lab. You've probably seen it if you've done any AI before. Here I'm using ChatGPT to show horsepower is the strongest predictor of retail price in correlation. And it's just how I prompted the model. I'll start from sort of the low-hanging fruit, like just prompting and getting insights with your data as you just upload it into your Gemini app or your Meta AI app or your chat bot, whatever have you. But here I'm a persona of maybe I'm a car dealer. I have a lot of cars in my parking lot. I just took away that more horsepower means a higher price, right? I'm going to actually sort of drill down into this a little bit more. Microsoft, right in 2023 when ChatGPT launched, there was somebody I consider a mentor, or he doesn't know he's a mentor, Victor Dibia, who's a principal researcher at at Microsoft Research, sort of launched something called LIDA, which is hosted at this site, Microsoft GitHub pages landing page here. And it actually did something very interesting that reasoning LLMs or large language models today are doing. And at the time, this was like novel to me. What it would do is this same CARS data set, if you got this running, it would summarize the data. It would, generate a set of potential goals for you or based on what you're trying to do, just so that you don't have that cognitive load. I'll talk about that here in a second. It would then choose a visualization for you, because when I was starting out several years ago, it was very, very tough for me to figure out what is the best way to visualize a bunch of tables and columns in a database or a CSV. Like, what visualizations? I didn't have that background because I wasn't a data scientist at the time. And then it takes it a step further and just gives you really cool infographics with that. For lack of time, I'm not going to show that demo, but it's really awesome. It takes it a step further than what you can do. Actually, that's not true. You can actually prompt your GPTs to do something similar. And again, I want to attribute Victor at Microsoft for building such an awesome product that inspired a lot of what you're going to see later in this workshop. So that's LIDA. So let's jump right into the why. Let's examine why open data remains inaccessible. I just want to double tap into that a little bit, and then we'll come back out and do another cool demo. First, there's technical barriers, complexity, right? Data comes in so many formats: CSVs, JSON, RDF, XML, and I used to work for USDA, their FPAC, and in our CS division, there was also additional complexities. So you had geospatial data on top of that. So, GeoJSON on top of that, there was scientific data that I had to grapple with. And each format is its own structure, and it requires different tools and processes. And I often see non-technical users struggle with even opening the files, let alone manipulating them and running them through pandas or Dask in order to sort of see the head of the top 10 just to analyze that data. And that diversity makes data often hard to access, right? So that's the first. The second is the skills gap. Like I said before, you almost have to be a data scientist. So even if you're talking to Claude or Gemini or OpenAI's ChatGPT, like how to ask it a question of your data set is often difficult. If you're looking at a database querying is often required for larger data sets, and how to wrangle that data, how to learn SQL on the fly if you just want to understand the data from an election in your part of the world. It's really hard. And then lastly, actually next to last, is that this cognitive load problem. There's by that I mean a mental effort required to process this information. Like you're coming into Excel, you've loaded your CSV, or you're looking at a dashboard. I used to be a product manager, and I would just sort of look at Google Analytics dashboard, and I just don't know where to start, and I'm sure a lot of you can relate to that. That mental overload of traditional data analysis creates yet another barrier. And this is the last sort of why. And then we're going to go to a poll. And Dahlia, if you want to paste that poll now in the chat. But I talked about the cognitive load. Let me sort of tap into what I mean. Again, that mental effort required to do some of this stuff is overwhelming. And research actually shows that AI tools can significantly reduce the load in data, but it doesn't do that in isolation. You still have to understand the types of insights that you want to derive from the data. So I guess I'm going to plow on, but this is your chance to scan the QR code here or just type it, go to menti.com and use this code 28392942 to answer that first question. We'll address that in the question and answer portion of this chat. This is not real time, so it's not updating. But I'll switch to the live poll afterwards. Actually, I'm very curious. I see one answer here, so yeah, just keep the votes coming. All right. Next demo, I promised you 2 demos. I skipped one, but so this one sort of answers some of the questions with the traditional approach that the problems with the traditional approach of analyzing data, right? Traditional approaches to analyzing data is useful to help you access data, but what if we could basically do better? This demo you're about to see, I'm going to switch to it, is my smart home dashboard. I'm not going to talk about what it does, but it does a lot of cool things. I have an interface at home that uses, in the US, United States Postal Service provides a service where they email you a picture of the letter that you should expect later in the day. So they actually take a picture of every single mail item. And I actually love that. So I had an agent. I built a little agent using Hugging Face's small agent to go out and check my email with the Gmail API. And what it does is that it lists all of my physical mail in this. But then I wanted to take it further, right? This is a local version of it. So for every tool call, actually, I should define what an agent is in the simplest way that I know. It is a way to get a large language model to reason. It is a way for it to call tools. So in this case, it is making a decision to go into my Gmail securely, find the USPS or Postal Service digest email, and then publish it via an API, which is a component in React that I then serve. This, by the way, is obfuscated. It's not my real mail, I should say. But then I get insights and as to what it is, and I can sort of slice and dice. How many times have I gotten? What's the most important mail item that I've not checked yet, or something like that? It also does things like energy usage patterns. So you should see a tool call for my energy patterns here. I can see in the house which devices get the most electricity. But this is just the React app. Like you're thinking to yourself, what's the magic happening here? Let's say I see a visualization that is dense with data and I just don't understand how to do it. So I'm familiar with, say, a pie chart as a pie chart. So here, the LLM is going to reason through that and then display a pie chart of the same data. I don't like this. Make it a donut chart, right? But that also implies that I know what a donut chart is. I didn't know that. I just heard somebody say donut chart, and this still doesn't make it. I just want a table. Oh, I changed my mind. Make it a table. Make it a table. All right, so here it's just going to spit out a table of the same data. Now, what you've just seen is just sort of the start of something pretty magical, right? What I'm actually building actually understands my intent. It's stateful, so it remembers what I prefer. So next time that I come in and I ask it for what devices use the most gas or electricity, it's going to give me a table, right, as sort of the default. And so now I've actually removed the work of having to chat with an LLM, even though an LLM is powering it. Anything, Arthur C. Clarke always said, any advanced technology is indistinguishable from magic. And for me, I shouldn't care what an LLM is. I shouldn't have to chat with a chatbot to get this. This is part of my dashboard, and I'm able to sort of get all kinds of experiences just with this, right? So but then some things happen. So I want to see this as a tree map. Show me something more advanced. I want to break this thing as a tree map. An LLM is only as smart as the checkpoint or how large it is. This is not a tree map. This is a line chart or something. So later in this video, we're going to talk about Gemma 3, which just launched by Google, and how I went through fine-tuning it. So I'm going from the easy, just put it in ChatGPT, to customize it with LiDA and just have LiDA do it for you, or something as advanced as this, and even more advanced, which you'll see here in a second, right? Here I'm sort of keeping all the history of everything, so I can sort of go through, and this is just a local version, so you can sort of see the parameters that I'm passing on, kind of stuff. All right, this is exciting. All right, cool. Let's go back to the demo. So how did I build all of this, right? To do that, which is actually sort of the core of this. Years ago, before ChatGPT, in 2022. I wanted to invent something called Katie, which I called Contextual AI Translated Insights. What I wanted to do at the time was to take sort of a smaller machine learning model and run it through an explainability or an interpretability library called SHAP, or Integrated Gradients, and then translate the explanations to different types of people. So if, let's say, I'm building a tool for, I don't know, let's say I'm Amazon and I want to sort of understand why the recommendation system recommended certain things for a group of people. Well, for an end user, I just want to know why I got these recommendations. Or let's say, let's use a better example. Let's say I'm applying for a loan. That's a great example. And I got denied. Katie would then explain to me, the user, why I got approved or why I got denied. And then all that is what we used, something called SHAP, Shapely Additive Explanations, to generate to infer the feature importance is what caused the model to give me this prediction or classification or whatever the predictive AI use case was. Well, that I sort of demoed that right before ChatGPT launched and realized the sea change over the next couple of months that nobody was really interested in machine learning models, XGBoost and old-fashioned smaller models anymore. So then I had Katie just written down. So what I did here was to sort of reframe what I wanted to do. And I love branding things, and I got into AI using, understanding and loving OCR, optical character recognition, later building a lot of tools using named entity recognition. So I built this thing, the next version of Katie, called ACR. So it's agentic component reasoning or agentic component recognition. Essentially, for my dashboard, I'm asking the system, show me my energy patterns. That is a client message that gets sent to a Next.js server. That then gets processed to my large language model endpoint, which can be OpenAI's API, Claude's API, or a fine-tuned model, which I'll talk about here in a second. The model reasons through and then analyzes the user intent. Or one thing that I'm still working on, which is just understanding the preferences so that it can keep, it can sort of look at me as a lookalike data and just sort of keep recommending that to me to save me from having to type something every single time, as you saw earlier. And then it generates the component. It literally generates the component based on the tools. And this is just a React component, right? And so the data is abstracted, is however you get your data from that. And that React server component streams that React component back to the UI, thus back to the user. And so it's what you just saw. That's literally how it works. So, if you're using Google and Google Analytics or some dashboard, BI dashboard, Microsoft Power BI, or what have you at work, you're probably familiar with this, and you want to sort of make sense of your data. You have to filter your data. You have to choose the right visualization that assumes that you're expected to know what chart type, for example, to select, which if you're not an analyst or a data scientist or product manager, you probably don't. And then you select your chart type, then you configure your parameters, and then you map that. If you've ever used any advanced app, you're probably just rolling your eyes right now with data mapping problems. And then it generates the chart, assuming that all goes well. Versus what I've just sort of demoed is a generative approach that simply expresses what you want to know about the data. Show me energy usages by day of the week. Show me this as a donut chart. And then the system handles everything else for you. Again, indistinguishable from magic. It has to be explainable, though, and you have to sort of handle a lot of the tooling responsibly and the data responsibly, obviously. I'm doing this because I'm following patterns, data trust patterns, for example, UX or user experience patterns as well. Traditionally, if you ever filled out a form, it just collects all of the data, but a data trust pattern is only collect the data that you need. So you can imagine this type of tool or a generative UI solution for, filling out forms. In this example, I have the regular old dashboard. It gets very complex when you start having tooltips to explain it. And then, of course, jumping from one filter to another versus sort of having that progressively disclosed. So when you saw my demo, it was just one thing, one interface, and just not the noise of a whole bunch of other interfaces. So, as you saw, I tried to ask it for a whisker chart or some advanced or tree map, I think it was, and it gave me something completely different. Well, that's because the model didn't really know how to understand. I'd probably never seen what a whisker chart for my recharts library that I was using. So what I did, or what I'm doing, is sort of use Gemma, Google's new open source model. It's an open weight foundation model that is specifically designed with fine tuning in mind. And I feel that it, depending on the checkpoint that I use, if I want the 2 billion parameter version or the 7 billion parameter version, that whichever one I can sort of test, I have full control over the LLM to check its reasoning capabilities and contextual understanding. Gemma also has permissive licensing for me, so I can perhaps bring this to market if I was so choose. But I'm actually making this open source. This model is going to be available on Hugging Face under I'm just Stig's Foot. If you're ever interested, I'll provide that as a resource, or Dahlia will provide that as a resource to you as part of this talk. So yeah, I was able to sort of use the architecture because it's optimized for efficient fine tuning, meaning I can adapt it for our specific needs with less data compute, depending on which size that I got, parameter size that I used, that would be required for other models. So control is, oh, geez, I didn't finish this slide. But fine tuning for me, just to define what fine tuning is real quick, for me, if you look at sort of the knowledge cutoff of most foundation models, a typical foundation model is back propagated to the data that it was trained on. It doesn't know how, in my case, components, open source components like D3 operate. And so in order to fix that problem with where it screwed up the tree map, I'm going to sort of teach the model new tricks through this fine-tuning method. Actually, a simpler way to define fine-tuning, and if you're a data scientist in the audience and you disagree, please call me out in the chat. It's just supervised learning. It's basically I'm giving it a bunch of example question answer pairs, like a question, what is my energy usage this month? And the output that I expect would be a tree map or whatever that makes sense and then should train it with just like kind of like traditional machine learning. Second poll, same place that you were before, right? So I'm gonna, whoops, I don't know. The second poll, I didn't even think I needed to do this. I'm gonna do it like, how are we doing on time? I got about 15 minutes and turn it over for you to ask questions. I'm sorry I had to do this. I thought I could switch it. So I want to end this poll. I don't know how to do it. If you can ask this, so I think it's the same one. I didn't even run through this yet. I'm sorry. I don't know how to end the first poll and start the new one, but see whether you can vote on the second poll. And again, like we did last time, what aspects of fine tuning are you most curious about? Hopefully I tackle a lot of those today for you. But yeah, hopefully the results things works. Oh, wait. Okay, never mind. Anyway, so hopefully it works. If it doesn't, it's fine. We'll keep it pushing. All right. So I mentioned fine tuning, right? Hold on a second. Let me get back to, I don't need this. I was going to show you guys my Visual Studio Code stuff, but I'm not going to do that. Anyway, so for fine tuning, the first step of fine tuning is data, as you would imagine, right? And so the first step is sort of collecting your training data set. This is actually really, really useful later when you want to evaluate the performance of the model as well. So again, I have query component pairs as part of the source. First, I got to create some synthetic data for creating those query component pairs. I also want to use real world examples. So there's a lot of handwritten examples, stuff that I can find online, collect that data, process that data, evaluate, split that data and prep it for fine tuning, and then fine tune it. Okay. The quality of the data set directly impacts the model's performance. And so just keep that in mind. Here's an example, just one example of those question and answer pairs that I was talking about. In this case, it's the instruction to the LLM. It is, so this is the supervised fine-tuning equivalent, so it's supervised learning equivalent here. I'm asking it, show me energy, time, and an example of the output, what props that I expect back, and do that over like 200 or 500 times, however many, and just evaluate based on that. The important point that you have to remember is to include variations in the phrasing and even in the outputs as well. Make sure that, how do I say this? You ensure coverage across different visualization needs and temporal patterns or comparisons to distributions. And then again, this is not magic. It's an iterative process, and you just have to test and evaluate with real user interaction. So human-centered design and how you sort of test with your SMEs or your subject matter experts or your end users is still important. How did I do this? So technically, I used Hugging Face's Transformers library, something called a qubit, a 4-bit Q LoRa fine-tune of Gemma, and just a lot of jargon, but essentially I tuned hyperparameters like batch size, learning rate, training like how many times to train it, to backprop it, in order to find the optimal balance between accuracy and training time. I'm using a 4-bit quantization because I don't have the compute to load an entire model. And so that's an efficient way to do that. Some decisions that I had to make along the way. I picked my model based on my goal. I figured a text-only model was sufficient, right? Because I'm visualizing things like tremor, D3, recharts, that kind of stuff. Am I still sharing? Does anybody know? Anyway, another one was size, right? I was sort of torn between the 2 billion parameter and the 9 billion parameter. I don't have the money because this is just a labor of love for a 9 billion parameter model. So I went with a smaller model, which is kind of struggling with complex visualization. So I may have to figure out what to do next before I update the model on Hugging Face. Specifically with the 2 billion parameter model, I'm using Colab Pro and A100 GPU. That seems to be, it's like $15 a month or something like that. I can't remember. Anyway, so yeah, Gemma 3, Colab, trained on Tremor, Recharts, D3 to start. Trying to figure out here. I see a lot of questions coming in. Hopefully someone is keeping track of all of this stuff. Can you make it full screen, please? I'm so sorry. Let me do that. Is this any better? Sorry, I didn't see that message earlier. Are you seeing speaker notes or just a thumbs up or a yes if you see my speaker notes, which is fine if you do, but
Yeah, thank you, Nabna. Yeah, now it's good. It's full.
do you see my speaker notes as well?
No. We just see
Okay.
full screen. Yeah, thank you so much.
I'm so sorry. I wish I'd looked at the comments earlier. Anyway, we're almost at the end, so we can sort of go back to certain slides if you need. Anyway, so there are 3 pieces to this. There's the cloud infrastructure part. You can use any cloud infrastructure if you're AWS, Azure. In this case, it's Google Cloud Platform. I'm specifically using Cloud Run. And then, of course, in the middle here, you've got the data communication layer of essentially, and then, of course, the client side. After fine tuning, you have to sort of serve it, right? Serve the model. And so whether you're using VLM or whatever scheme you're using to sort of have your client or your application ingest or understand or use the API that you're serving for the model. You do that. In my case, I use Nest.js. I actually sort of refactored a solution by Vercel. So I just want to give them attribution for that. And just it's completely different now. I basically just ripped out a lot of their code because I think it was a chatbot when I started, and now it's not. Anyway, I use SSC to enable streaming updates to the UI and to process the requests. And I'm using a couple of tricks to actually give the end user something. So parts, I progressively sort of, deliver some of the content as I'm streaming it back so that the end user doesn't feel like they're waiting for something. And so as you sort of saw, I'm using a lot of neat tricks with that demo that I showed you. All right. Challenges. It wasn't, it's still going on. So before I had sort of a complex dashboard. Again, I was talking about the Google Analytics, but just replace this with any traditional dashboard. After that, you had what I was showing before, which is just a clean interface, clean visualizations, progressively disclosed, and it just keeps adding on. And I could probably come back to this. This is just a silly home automation example, but you can imagine using this for actual applications. One use case that I've heard of is accessibility testing. Another use case that is really popular or folks are really interested in using this is for A/B testing after you ship your solution. So again, I'm just building the framework and eventually a library for you to consume. So we'll see where this goes. But I have been doing some usability testing and got some metrics. I've noticed almost a 90%, 87% time to insight, which is really, really important. That was one of my objectives. And then hopefully another target is whether I haven't run this experiment yet to see how much increase I get in data exploration for certain use cases. What I intend to do is to redo what Victor Dibier and the Microsoft research team and just sort of bring it into the world of generative UI. And so basically just upload your CSV and use this approach to, the modern approach to do this versus what they delivered. So along those lines, eventually, I'm sure, depending on what users want, I might expand on more libraries. This is, again, open source. I'm a one-person shop, and so forgive me. I also want to publish versions of this model online, and who knows? I don't know what's going to happen in the future. I can imagine specific applications implementing sort of voice agents. Again, I can't predict that. That's going to come from the community as to what you need. So key takeaways before we end. You've taken away that open data has an enormous amount of untapped potential. Old school interfaces are dying, in my opinion, based on, how we're sort of used to it. I think I really feel like we need to sort of challenge that thinking. I believe that generative UI, which, by the way, you use, whether you know it or not, if you've ever used ChatGPT or Google's Gemini, you're familiar with Canvas, or I think Claude calls it artifacts. That is a form of generative UI, right? And so you're chatting with it and it changes the UI in order to sort of present you. If you've ever used sort of Google's Gemini app, you probably know exactly what I'm talking about. All right, so yeah, so if if you build something like this with generative UI and you realize that your open model or your proprietary model is sort of not performing well, and hopefully you're evaluating along the way, you'll slowly discover fine-tuning, which is a way to sort of teach the model new patterns or tricks. It doesn't teach it new models, nor does it eliminate hallucinations. Just want to say that out fast. It just sort of teaches it your specific domain and things that you want it to learn versus sort of the backprop, the old world model that LLM knows how to do. Yeah, and I want to end with the future of data. Hopefully it's adaptive, it's conversational in where it matters. It's also accessible. And this is how you can find me. I really would love you guys to subscribe to my YouTube because I actually explain generative UI in simple terms. None of these other links matter. Just join this YouTube or subscribe to my YouTube. And if you guys engage with my content, I want to do more of this, and I want to do more of this if you're sending me those signals. So please subscribe, join, follow this project on my GitHub as well. But none of that matters. Just subscribe to my YouTube. That's all I want from you. Dahlia, I'll hand it back to you for questions.
Thank you so much, Noble. Really, this was very insightful and very beneficial for, I think, for me personally and for, of course, all the attendees. But really, thank you so much. So yeah, we appreciate how you helped us to understand more how to use the AI-powered visualization to make the open data more accessible, more easier to analyze, to understand, how to, I think all that, this is what we need now, these days. So thank you so much for this session. So before we go to our Q&As, I will put in the chat the link to our survey. So in order to know your comments, your feedback, how would you like us to improve our webinars, our services? So please go and it will take 2 minutes. So I put the link in the chat. Please go, just complete the survey so we can collect all your feedback or your comments. If you would like to suggest any topics so we can tackle in the future webinars. So please go ahead and complete the survey, and then we will start our Q&A session. Please go and put any question you have in mind in the Q&A chat box, and we will start with the first question. What makes open data challenge? Is it lack of programming language or what?
Well, I covered that initially. There are lots of challenges. There's the technical barriers that you have to know what format to manipulate the data. There's a skills gap. You almost have to be an analyst depending on the types of data, or data engineer in order to sort of manipulate the data. You have to almost be like a data scientist, right? Like you almost have to know you've got this raw data and you want to be able to tell a story with that data. And so you have to understand what's the best visualizations for you to grok or understand that data in order for you to tell that story. That has historically been a barrier. When I was joining, I didn't know what kurtosis was or what a whisker plot was. And so I had to really learn the hard way. And so hopefully that answers your question.
Thank you so much. The next one is, what is the URL for downloading this tool? Which
Tool?
one? Yeah, actually, Ale
So
Night.
Light, which is published, is available at, I'm going to try to remember here. It's Microsoft. I have it open here somewhere. I'm going to paste that in here. It's microsoft.github.io/Lida. I would warn you that in order for me to get it working, because this was shipped, I don't think it's supported anymore because I haven't seen a lot of updates. The model, the library wants to use a deprecated OpenAI 3.5 turbo model. And so you have to know how to change, get it working. That's why I use sort of a Google Colab version of it. I can make that available to this audience if you want to sort of skip. So I'm keeping a list of things that I want to send you. So I'm going to add that. And then I'm going to add the Colab notebook, make that available to you as well. If I'm not looking at the screen, Dahlia, if you want to hit me with the next question.
Yeah, sure. Okay, so how will AI evolve in business intelligence and analytics? What specific tools are relevant to it?
How would it evolve in BI? What tools are? Oh, okay. So I think the whole point of this presentation covered that, right? Like I think analytics will move and BI will move from just traditional dashboards to what I call contextual insights, information when you need it, out of the way when you don't, even in the context of AI. It could be conversational. I would imagine some NLP-based or LLM-based involvements in it, and that's how I think it's going to evolve. If I get my way and this becomes a thing with generative UI, my concept of agentic component reasoning or recognition becomes the mainstay, where components that you build in your Angular apps or your React app become intelligent, where AI is selecting the right visualization or the right UI component for the right data pattern that you need, which is why I'm making my fine tune of popular visualizations public. What else? I think we're going to move, if you're familiar with the different types of analytics, this is a great question. If you're familiar with the different kinds of analytics, there's an old school paper about descriptive analytics, which is looking at lagging data, like historical data, like what was my sales last month, that kind of stuff. And we're going to move from that to more diagnostic analytics, which is, so how did we get to this answer? And then you can get to diagnose that. And then more prescriptive analytics, moving beyond like what might happen to what should I take with prescriptive analytics. And then someday, who knows, it's more causal. Like I can probably say, this is why this happened with a level of confidence. And this is what actions you should take to prevent it, or maybe run a counterfactual analysis based on that. So yeah, that's my answer to that question.
Thank you so much. The next question, can you talk a bit more about synthetic data and how to work with, for example, chat GPT to get some?
It's ChatGPT is helping me out quite a bit, or an LLM, I'll just say, not necessarily that LLM, but I would caution that you temper AI generated data, synthetic data generation with human tuned or at least augmented subject matter experts in that data, and just sort of, it's sort of a balance. And then for that is an LLM is only as good as how you prompt it. And I'm sure you're probably going to, optimize your prompt to make sure that your data set, your 100 or 200 examples are accurate. But how do you know that every variation is either diverse or representative of whatever your business goal or your whatever you're trying to achieve is? I think you still have to, nothing changes if you're familiar with old school data science or machine learning. You still have to do the legwork of understanding your data. So knowing your data, regardless of how you generate that data, is imperative. And so I can't just say, go and an LLM do the, synthetic data generation. You'd notice that on one of my slides, not only did I include synthetically generated data, I also included real world data, and that includes like stuff that I'm writing myself, so custom components that I've built in the past and that I want it to be able to spit out. And so yeah, just keep that in mind. And also evaluate, like learn how to understand know your data from pre-proc, know your data in proc while it's, you're training, whatever, know your data post proc. So as your end users, post processing. So as your end users are interacting with it. And the only way to do that is to have, tracing or logs and understanding, the entire experience, the entire end to end of said data.
Okay, perfect. The next one, can we get the code of your work if this is open source?
Yes. I'll do you one better. So I'm adding that to my list here. I'm gonna make the dashboard that I shared available. There are also other ways to deliver generative UI experiences for more advanced and smarter people than I. LangChain and LangGraph have, if you do a search for generative UI LangGraph, Bryce, I forget his name, in the LangChain community, or might even work for LangChain, has a bunch of open source solutions or examples on GitHub. So I'm adding that as well. Bryce Sproul, I think his name is Bryce Sproul, LangChain. And I'm going to add that. I'm going to just hit enter in my chat, so you'll see a lot of this stuff rather than spamming you every single time.
Thank you. And yeah, we can share it in the community as well. Can share everything after the webinar.
Yeah.
Okay,
So
perfect.
I'm gonna paste this in the chat. So when I finish chatting with you guys, so this is the next question.
Okay. What industries or sectors can benefit the most from AI-driven insights on public data?
The question again?
What industries or sectors can benefit the most from AI-driven insights on public data?
Every industry. This is very think about it. Name an industry. There's a reason why data is made open by nonprofits, by organizations, by governments. And this is because if let's say if you go to data.gov, you're in the US, you can be anywhere in the world. You'll be able to sort of see all of the data that is available to you. My previous line of work, I mentioned I work for USDA. USDA is mandated, well, the Department of Agriculture in the United States. I work for soil scientists. These are really brilliant individuals that deal with a lot of geospatial data. And for every farmer out there, for every academic, they expect peat-on data or soil types or ecological data. And by law in the United States, I'll argue in the EU as well, you have to publish this data. If there's been if I, let's say, want to understand the makeup of soil in my region, this is data that's going to be available to me. For any industry, if I'm in real estate, I may want to make sure I don't want to build on eroding soil or whatever. If I want to sort of see what is killing my plants as a farmer, I may want to understand, a cross section of the data. And my job for NRCS was to help them publish this data, and it had to be Geospatial Data Act compliant. It's an ISO standard 19115. Any industry that deals with the earth beneath us in this narrow example, I would argue, could use that. And so it's a great question. It's just any open data is the best thing that ever happened to a lot. Europeans have the European data portal that aggregates data from EU member states. Of course, I've talked a lot about data.gov. World Bank has open data sets that you can use and better understand what's happening around you. NASA has open data. CERN has data. If you live in New York has comprehensive city level data, which is amazing for visualizations. There's also Kaggle or Hugging Face or data.world or Google Dataset Search. Or if you want real time, I believe X or Twitter has, I don't remember if they still have this, but they used to have like a Twitter API that you could use, or Open Weather Map is another one. And so, yeah, I love that question. I'm sorry, running out of time.
Thank you so much. Okay, we can take like one last question. We have still 1 minute. So, final one last question here. Was it difficult to get running on cloud? So only Gen AI programs are running on cloud?
It depends. So yes, is the easy answer. I'm not a full-time AI researcher, applied researcher. I do not work for OpenAI or build these models. And for me, it was very difficult because in order to sort of deliver this, you have to understand sort of end-to-end software engineering. So from the machine learning operations portion, oh, sorry, from the data engineering part, like, from when you gather your data, how to house your data, how to create your pipelines, making sure that that's right, that those are all can be run on the cloud, to training or fine tuning that, unless you have a beefy machine and a lot of GPUs, NVIDIA just launched, some available personal computers that you can actually sort of run these types of inferences on. That's great. That's good for you. But you can run that on the cloud as well for a fee for the most part. VLLM is one source where you can sort of just rent GPUs. Vertex AI has tools for that. Azure, I'm sure AWS has Bedrock that you can use as well. And then on the front end, you can host it. I use Firebase and Vercel and a whole bunch of other tools depending on what I'm trying to do in order to sort of serve this data.
Thank you so much, Noble. So it was great having you today with us, and really it was very insightful and beneficial for all of us. Thank you so much for your time. Thank you for joining our tech webinars, and thank you all for our attendees, and I hope to see you in our next webinar. Thank you. Have a great day.
I
Thank you.
provided the links in the chat, and definitely if you want more of this kind of stuff, please help me get onto that YouTube and spike those numbers for me. Ciao.
Thank you so much. Thank you so much now. Okay, bye.